Previously, I gave you a limiting reagent problem, but did not work it through. And so now I'm going to. So we had 3 moles of zinc reacting with 2 moles of iron 3 bromide, producing 3 moles of zinc 2 bromide and 2 moles of iron, elemental iron. And this reaction proceeds with 87.3% yield, 43% yield. So it doesn't proceed at 100%. Percent yields have to be determined by experiment. So there's no formula to get that unless you've actually done the reaction. So don't worry about where that number comes from. So now we have to calculate grams of iron. That's what the problem was asking for. So some helpful information. 1 mole of zinc weighs 65.38 grams per mole, and 295.55 grams per mole is the molar mass of iron 3 bromide. So we have the molar masses that we need. So now we have to work through the problem. Again, pick one reactant and then go from there. So let's start with the zinc. We have 450 grams of zinc and we are trying to calculate grams of iron. I did not give you the molar mass of iron, which I'm going to do right now. That's 55.85 grams per mole. Again, you'll always have a periodic table, but I'm just trying to help this along. By the way, the biggest problems that I've seen as far as being able to solve a limiting reagent problem is, one, not recognizing that it's a limiting reagent problem, which you should do if you're given multiple reactants and the quantities of those reactants. In other words, if I'm given only the zinc and told I have an excess of the iron 3 bromide, it's not going to be a limiting reagent. But when I'm given a mass of each one, that means I have to figure out which one do I run out of first. The other mistake is taking these two values and adding them together. You have to realize that the calculations are going to be separate. And it is so tempting to just smush everything together to do one equation, but that's horribly wrong and won't give you anything even worthwhile. So you have to do it separately, recognizing that one of the calculations is going to be wrong. Okay, so we have grams of zinc, and we want grams of iron. So let's convert to moles of zinc. That's always a good starting point. And see what that gets us. So 65.38 grams of zinc is 1 mole of zinc. Grams of zinc canceled. I'm in moles of zinc. Now we can use our balanced chemical equation. It's a 3:2 molar ratio. 3 moles of zinc is equivalent to 2 moles of iron. You have to use the balanced chemical equation. There's no other way around it. Moles of zinc cancel. Now I'm in moles of iron. And we want grams of iron. So 1 mole of iron, 55.85 grams of iron. Moles of iron cancel. We have grams of iron, so now we're ready to go for the calculation. So 450. Oh, I'm about to screw up my own problem. We're almost so close. So I caught myself before I made a fool out of myself on camera. I gave you one more piece of information. 87.43% yield. If I would have solved for this value, I would be assuming it's 100% yield. So how do you put 100%, how do you put percent yield into a dimensional analysis table? After all, I've just solved for grams of iron. I'm done, right? But here's what we have to do. And as you can see, it's very easy to forget to do that. So we still want grams of iron. And here's the trick we can do. 87.43 grams of iron. So what that says, for every 100 grams of iron isolated, for every 100 grams theoretically that I should isolate, I only actually isolate 87.43 grams of iron. Notice that my units are both in grams of iron. So the result is grams of iron cancel, but I'm still in grams of iron. It's kind of silly to do it that way, but it actually does work out with the units. Because in 100% yield, this would be 100 divided by 100, so we don't even bother putting that in there. But I have a non-100% yield reaction, so I must take that into account. The other thing, if I would have solved for the number, ignoring this, I could also multiply by 0.8743. Mathematically, it's the same thing. Okay, so now I've included my percent yield, so now I'm ready to go as far as picking up my calculator. All right, so 450. And I get 224.1 grams. Let me rewrite this. Double checking my significant figures. So 224.1 grams of iron. Okay? That's with our 450 grams of zinc. So now I redo this calculation, but based on the iron 3 bromide. So we have 927.0 grams of iron bromide. And we still want grams of iron. Put this down. We use the same procedure. So we have grams of iron 3 bromide, but we want grams of iron. So the molar mass of iron 3 bromide, 295.55 grams of iron 3 bromide for every 1 mole. Again, grams to moles conversions should hopefully be coming second nature at this point for you guys. Grams cancel, we have moles. Now we can use our balanced chemical equation, and it's a 2-to-2 ratio. So for every 2 moles of iron 3 bromide, we produce 2 moles of iron. Moles of iron 3 bromide cancel. Now we're in moles of iron. And now we can finish the problem exactly as we did for the previous one. except I won't forget to put that in there, hopefully. So 1 mole of iron (55.85 grams) of iron. Moles of iron cancel, and now we're in grams of iron, but again, we have to use our percent yield that was given to us. So for every 100 grams of iron that I could produce, so that's in theory I could produce 100 grams of iron, but I only isolate that 87.43 grams of the iron. Okay, so now we have grams of, again, grams of iron cancel, but I'm still left with grams of iron. So 927 times 2 times 55.85. And I get 153.2 grams of iron. 153.2 grams is smaller than 224. Therefore, iron 3 bromide is the limiting reagent, and this is the maximum amount of iron that I could produce. If I would have forgotten to put in the percent yield, I could still identify which one was my limiting reagent, because this would be about 12.5% higher, and so would this, so the relative values would change, but they would just be wrong in the sense of I asked a problem where I had a percent yield. That wasn't 100%. So again, I threw several concepts at you in this one, but again, 1, 2, 3, 4 conversion factors for each of these. Again, this is where dimensional analysis pays off if you know how to use it. If you don't know how to use it, you're going to be in a lot of problems. So take the time, work through this yourself if you haven't already tried it. If you didn't get the same answer I did, go back and repeat it. So 153.2 grams of iron.